then I can kind of do it in my head real fast. Like for instance, I know the tangent of 0 is 0. I know the tangent of 45 is 1 because sine and cosine are the same thing. And I know because it's 1 over 0, tangent of 90 is undefined. So those, as you go on, they will come pretty quickly for you. For me, the big question is 30 and 60. And so 30 degrees, I know is 1 over square root of 3, which becomes root 3 over 3. And 60 is root 3 over 1, which is just root 3. So I'll do it real fast in my head, the 30 and the 60. But, yes, sir? Here's what I heard. I heard on the homework last night, could we just
use A, B, and Y?
A, B, and Y? I don't know what A, to be honest, I don't know what you're talking about.
Instead of.
So it doesn't mean. The variable what? Look at this.
I don't know.
Alpha, beta,
Theta.
beta.
No, but isn't there a theta?
Yes.
Gamma.
What about the one that was gamma?
That's that. Yeah, it kind of looks like a Y if you kind of. I did a bigger loop at the bottom. What they did in the book is they do.
Do we have to use those or do we use A, B, and Y?
Well, learn.
Well, I didn't know.
Learn. L-E-R-N. Learn.
Persevere.
What?
I don't know.
I was prepared to just let him go with its spelling, but then I thought about it.
It's
and I'm like,
gonna
wait.
be here for the rest of this year, all of next year, everything like that. So just start getting used to it. That's all.
15 minutes?
All right, go. Questions. Where do we start?
I can tell.
41.
It's not healthy. No, but it's not abnormal. Sleep takes years off your life. It's not sleeping takes years off of your
I heard 41.
Perfect.
Is that correct?
Good, but it's not healthy. I don't need years of life. Give me time, like,
They said if the longer leg has a length of 12. What is the shorter leg and the hypotenuse? Okay, so when we talked about this, I don't know, yesterday, we said that this was 1, 2, square root of 3. Fair? If you want to, instead of saying 1, 2, and square root of 3, you could say x, 2x, and x root 3. If you want to do that. Some people will teach it that way also, and in a situation like what we're about to talk about, it's probably better to look at it this way. If we have this, and we're trying to find this, what do? 5 by the square root of 3. So we will take this, divide it by the square root of 3, and have radical in the denominator, so we'll do that, which gives us 12 root 3 over 3, which becomes 4 root 3. Does that make any sense? So divide by root 3. If we have those two, how do we get that one?
multiply by 2.
Yeah, since this is x, that's 2x, we just take the shorter leg and multiply it by 2, which would give us
8
root 3. You got it. Okay. Next. 73.
Wait. So the square root of 4 over 2 and then take out a 1 or 1?
The square root of 4 over 2 is 1. Right?
Yes.
So to do 73, we have to read the background material first. You archery stuff. By the way, the picture does not translate to what they wrote, which kind of causes a little bit of a problem. So I went with, when I'm doing it with what they wrote rather than the picture. Because in here they start talking about like the black circles, and I don't see any black circles. Maybe I'm colorblind, but I see kind of yellow, orange, and then red circles, and then blue circles. That's what I see. So I think what they wrote is probably the way to go.
Wait,
I haven't even started yet.
I should have asked you about last promise.
Yes, you should have.
Okay, wait.
So we're doing this one now.
Okay, I just want to know why it'll be multiplied by radical 3 over radical 3.
We're doing
And
this
look how
one
you
now.
still ask me the question.
Because you
We're
were
doing this one now.
Because you have to
So-
rationalize, you have a.
Okay.
We have a point in the middle, okay? 4 inches out contains the yellowish rings, yellow and orange rings. 8 inches out contains the red rings, there we go, much better. And 12 inches out contains the blue rings, okay? And then they give point values and everything like that. So we'll come over here and look at 73. It says, assume that at the moment prior to releasing the bow, the arrowhead is directly in line with the bullseye. So we are firing it right at the bullseye. What's going to happen after we shoot it?
It's
It's going to go fast, but it's going to go down because
Gravity.
gravity. Okay. If the force with which the archer releases the bow is such that the arrow falls 3 inches vertically for every 20 feet the arrow travels horizontally, what is her score for the shot? So, what I would do is I would say 20 feet horizontally over 3 inches vertically is equal to, I did forget to go over the point which says,
Yeah, it's 50.
yeah, 50 feet. The archer shoots it from 50 feet, so horizontally 50 feet away, and vertically X. And there's our proportion. Does that make sense? Cool. 20x equals 150, x equals 7 1/2. So what did we find?
The distance is
Drop 7 1/2 inches, which means it will be
between 4 and
between 4 and 8 inches from the bullseye, which therefore means that
8 points.
she will receive
4 points.
20 points. If she wants to get better,
Aim higher.
aim higher. Does that make sense? Next. Going once. Going twice. Good.
Yesterday? It was mostly
Okay, so the good news in lesson 6.2 is that we did a lot of 6.2 yesterday. This is 6.2. This is 6.2. So, bad news is that we still have stuff to do, but we're part of the way through it. But one of the things that they tell you in 6.2 is memorize that. And I don't know if I've made that clear to you guys yet.
No.
A little bit. You know what'll make it really clear? Quizzes. Those quizzes. That'll make it very clear and obvious that you should know it. When your grade starts going, because you said, yeah, whatever. All right. So here's what some of the stuff that we know already. Sine of theta is equal to opposite over hypotenuse. Fair?
Yeah.
Okay. cosine of theta is equal to
Adjacent over hypotenuse.
adjacent over hypotenuse. Tangent of theta is equal to
Opposite over adjacent.
opposite over adjacent. Okay? And that's wonderful. By the way, guess what would happen if you did sine of theta over cosine of theta using all of this stuff?
You get tangent.
Which would be what?
Sine.
If we did opposite over hypotenuse over adjacent over hypotenuse,
Oh, opposite over adjacent.
you get opposite over adjacent. So it makes sense. You want the bad news? There are not 3 trig functions.
Oh.
There are 6 trig functions.
Oh. Since when?
Yeah.
There have
Since
always
now.
been 6 trig functions.
Oh.
I am not inventing anything new today.
No.
The other 3
We
are
don't want to
called
know
the
about.
reciprocal functions. And they are, in this order on purpose, cosecant, secant, and cotangent. And you are going to need to know these also. Cotangent, you want to take a guess at the abbreviation for cotangent? COT. These 3, cosecant, secant, and cotangent, are the reciprocals of the functions that they are right next to. That's why I put them in this order. So cotangent is the reciprocal of tangent, which therefore means that cotangent of theta is adjacent over opposite. Secant, abbreviated SEC, secant of theta is hypotenuse over adjacent. And cosecant, abbreviated, if it were COS,
It'd be cosine.
it would be cosine. So that one's already taken, so we got to come up with something new.
COE?
And they have come up with CSC. Cosecant of theta is the reciprocal of sine, so therefore it is hypotenuse over opposite. Okay? Therefore, what is the secant 30 degrees?
2.
2 over. Oh, wait.
Well, secant of 30 degrees is the,
Cosine. 2 over square root.
don't use that O word, the reciprocal, very important distinguish. You know what I mean?
2 over square root.
The reciprocal, which we can write reciprocal as 1 over, but it's the reciprocal of what? Cosine of 30 degrees. Now, we wrote it as 1 over cosine of 30 degrees. We don't want to do it as 1 over the cosine of 30 degrees. 1 over anything means
It's a friend.
give me the R word, reciprocal. 1 over something means the reciprocal. What is cosine of 30 degrees?
2 over square root 3.
What is the cosine of 30 degrees?
3 over
Square root of 3 over 2. So the reciprocal of the cosine of 30 degrees is
2 over square root of 3.
2 over square root of 3. We don't want to go through that 1 over thing. It just enormously complicates things. But
Can't have it.
can't have a radical in the denominator. So,
Rationalize.
rationalize with
Square root of
square roots of 3, which will give us
2 square root of 3 over 3.
2 root 3 over 3. So the secant of 30 degrees is 2 root 3 over 3. And
Instead, I would then make another chart.
no. What is the cosecant of 30 degrees? It is the
2.
reciprocal of the sine of 30 degrees. Since the sine of 30 degrees is 1/2, the cosecant of 30 degrees is
2.
we like that one better. Questions there? You okay with that? So, we now have 6 trig functions. Sine, cosine, tangent, secant, cosecant, cotangent, right? Okay. In a couple of weeks, we will bump that up to 12 trig. No, I'm just kidding. We don't have any more than 6. Now, we have 6. Okay? Good? Cool. So now we know all 6 of the trig functions. We also know which ones are reciprocals of one another. Give me a pair of reciprocals. Cotangent and tangent? Cosecant and sine. Or secant and cosine. Yep. Now, those are the reciprocal functions. They also have relationships. It's different. As cofunctions. Now, the functions that are cofunctions are basically exactly what you would expect. A pair of cofunctions are sine and cosine. Get it? Sine and cosine are cofunctions. Secant and cosecant. Tangent and cotangent. These are called cofunctions. The only pair that are the same, that didn't make any sense. The only pair that are both cofunctions and reciprocal functions are tangent and cotangent. Okay? What's the purpose of cofunctions? Good question. Here's the way cofunctions work. If 2 angles add up to be 90 degrees, in other words, 2 angles are complementary, then the sine of one of them is equal to the cosine of the other one of them. If 2 angles add up to be 90 degrees, then the sine of one of them equals the cosine of the other. Or the secant of one equals the cosecant of the other. Or the tangent of one equals the cotangent of the other. Does that make sense? So therefore, the sine of 30 degrees should be the same as the cosine of 60 degrees. Oh, wait. Sine of 30 degrees is 1/2, cosine of 60 degrees. Hey, they are the same. So therefore, what is the secant of 60 degrees?
Two.
How'd you get that? It's right there.
Oh.
That's why I'm standing here. I was trying to bring your attention in this general area. Yes, the secant of 60 degrees is the same as the cosecant of 30 degrees. So since the cosecant of 30 is 2, then the secant of 60 degrees is also 2. Does that make sense? Okay. We will use the reciprocal functions a lot more than we will use the cofunctions. We won't use the cofunctions all that much. But it is nice sometimes to know this, and it will be useful in some ways at some points. Okay. Questions there? All right. Let me ask you a couple questions. Can you give me two other ways to write the secant of b? Can you give me two other ways to write the secant of b? Okay, I heard cosecant equals cosecant of, I don't know what a is.
90 minus.
What do you think about that? The secant of b is equal to the cosecant of 90 degrees minus b. If b is 20 degrees, then 90 degrees minus b would be 70 degrees. 20 plus 70 is 90, so that works out. If b is 50 degrees, then 90 minus b is 40 degrees, and those are the angles that we want there. Does that make sense? Questions on that?
Yeah, why is it minus b?
Because the two angles have to add up to be 90 degrees.
Oh, okay.
Yes?
Yeah.
Okay. That is one way to write the secant of b. What's the other way? Careful.
Oh, 1 over.
Very different. 1 over the cosine of b. All three of these are the same. Now, very important, okay? When we are talking about the reciprocal functions, we are never, ever, 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 ever taking the reciprocal of the angle. Never taking the reciprocal of the angle. So it's not the cosine of 1 over b, it's 1 over the cosine of b. Okay? So jot it down somewhere, get it in your head somewhere, whatever you need to do. We are never taking the reciprocal of the angle. Never taking the reciprocal of the angle. Okay? All right, questions there? Flying. I'm going to erase the cofunctions. Can I erase the cofunctions? Let's see. Pick a color. There's purple. Purple. My question is, my request is, uh-oh. What I do now?
He went, is that a fish?
That is
Alpha!
alpha, the first letter in the Greek alphabet.
Alpha, beta, gamma, delta, epsilon.
We have talked about the Greek alphabet and the word and everything like that, right?
Yeah. Alphabet,
Alphabet.
I thought we did, just want to make sure. I would like you to find the value of the 6 trig functions of alpha. Okay, work together, talk. Find the value of the 6 trig functions of alpha.
It's doable, but may I use the restroom?
Ask that.
I'm dying.
You're dying.
Yes, I'm drinking too much water.
I know. One of these days, I'm hoping that she'll actually ask me a math question. That'd be really cool.
We have to find a sign.
The sign is alpha.
It's not there?
Well, I mean, sign.
Value of the 6 trig functions.
Is that one just gonna be opposite? Or is it? So to do opposite, sign is opposite of hypotenuse. Yeah, it's x because it's 30, 60, 90, so it's just x.
How do you know it's 36?
I guess. But either way, it would still be x because that's what the side is in both triangles.
We do. It's adjacent over hypotenuse.
Asking what the square root is.
I keep
So now we saw the sign.
Do we ever have much issue with it?
Hey, that's yours.
Out right now, is it possible to wait?
Yes.
Okay.
This is what you got.
Yeah.
Well, look, I run a backward by over it. Oh, what's that? And then we'll leave it like that.
Okay, wait. Pairs. It's fine.
So what would you like to know that you don't know this one? So how do you find, how do you get signed? How'd you get that?
Really not really.
So Pythagorean theorem. So a squared plus b squared equals c squared.
And what A?
What's a?
Well, we just do like one alpha. That sounds so good. Generation alpha. Alien race. My brother has generation alpha. What's that? Like the totally as they're cold and stuff. Skulls. Like, what is that?
You're done? X? X?
I mean,
Oh, how do we
x
get the third side of a right triangle if we know two of the other sides?
Oh, duh. X.
You're gonna actually use the calculator.
You had it. Why did you we gotta share. We're a group. We're supposed to be in this together, help
Right,
each
but how
other.
are we supposed to know
If you
it's
don't
a
know what to
30, 60,
do,
90 triangle or
You don't need
45,
that.
45, 95?
what can you use?
Pythagorean.
I don't know, I don't remember. Oh.
Okay.
Yay! See what I mean? We have to talk, ladies and gentlemen. We have to help each other out. Because I promise you, my turn for a second. If you know what's going on, but somebody else doesn't, and you can help them, there will be another time when they know what's going on and you don't, and they can help you. The more you work together, the better it's going to be for all of you, I promise. That's why you sit in groups of 4, not so that you can chat and socialize and all of that for an hour every day. It's so that you can help each other. Okay, what's this?
5.7.
Square root of 33, how'd you get it? Pythagorean theorem, you got it. So, the sine of alpha is
Square root of 33 over 7.
over 7. The cosine of alpha is
4 over 7.
4 over 7. The tangent of alpha is
Square root of 33 over 4.
the cosecant of alpha is
7 over the square root of 33.
yeah, it's the reciprocal of that, which would be 7 over root 33. But we have to rationalize with root 33. So that would give us 7 root 33 over 33. That's the worst 7 I've ever seen. That's not much better. It's still not very good. The secant of alpha, 7 fourths, and the cotangent of alpha,
4 times
so it's basically this same thing with a 4 there. So 4 root 33 over 33. Okay, now your question. Never mind.
Like, it wouldn't be the same.
I'm about to move on to something different,
I
so.
was just gonna ask, like, so if I put radical 33 over 7, right, the sine of alpha, and I guess we can kind of go with that, what is that?
You gotta give me a day or two. We're gonna get to that, but I don't wanna touch on it now because all it's gonna do is confuse everybody. And my goal, believe it or not, is not to confuse everybody. That's not what I'm trying to do. I may do it sometimes.
Right now, this is not confusing, it's just the opposite.
It's just the opposite of.
It's the reciprocal.
The
Reciprocal.
reciprocal, sorry.
Oh, you mean
Yeah.
this stuff. Yeah, opposite and reciprocal. Anyway, how are we on all this stuff so far? Yeah. Oh, you know what we can do to make us better?
Our whole
Problems.
Our homework. We can practice it on homework. All right. Last part of what I want to talk about today will be
Bye-bye.
calculator stuff. So if you have a calculator, get it out. If you don't, find
I
one.
can't find my calculator. Is it home somewhere?
We're going to do a very difficult concept, so you need to be paying attention.